Hello, dear AI enthusiasts. Today I have something for you that will blow your mind. A computer that runs on real human brain cells. Yes, you heard right. This is not a sci-fi dream, but reality. The people at Cortical Labs, an Australian company specializing in biological AI, have developed the CL1. This is a chip that combines living neurons with silicon, and it's faster, smarter, and more energy efficient than anything you've seen before. Imagine a computer that learns like your brain, but grown in a lab dish. Today, I'm taking you on a journey. First, I'll show you what's already possible, then we'll dream together about the future. But don't worry, I'll keep the facts and speculations clearly separated so you don't lose track. So buckle up, this is going to be wild. Let's start with what's already real. The CL1 is no ordinary chip. It has real neurons on it, cultured from human stem cells. The cells come either from adult donors who donate their skin cells. Yes, your skin can become something like this. Or from embryonic stem cells, all ethically secured, no shady business. These neurons grow in a special nutrient bath on a silicon chip equipped with 59 tiny electrodes. The electrodes are like small antennas. They can send signals to the neurons and simultaneously catch what the cells respond. To keep everything running, there's a mini life support system. Pumps supply the cells with nutrients, and the temperature is kept at exactly 37 degrees, just like in your body. The software is amazing. It trains the neurons with a reward and punishment system. When the cells do something right, they get clear, harmonious signals, like a "well done." When they mess up, chaos ensues, meaning random, confusing signals. That's how they learn, through trial and error, exactly like we do when we try something new, like riding a bicycle or playing a video game. An earlier version, the dish brain, already played Pong. The neurons figured out how to move the paddle without anyone telling them what a game is or what the rules are. The CL1 is the evolution. More stable, more precise, and ready for use. You can buy this now. Not a vision of the future, but a fact. And how exactly does the learning work? The electrodes translate digital inputs into electrical impulses that the neurons understand. When the cells then react, their signals are converted back into digital data. It's like chatting with your brain, just through a chip. Now to energy efficiency, because this is really a knockout. Your brain runs on 20 watts and can still play chess, lie, and dream. No computer in the world is that economical. The CL1 uses exactly this natural efficiency. A rack with 30 CL1 units consumes just 850 to 1000 watts. That's less than your toaster or your microwave. Compare that to large AI systems like GPT-3. They need millions of watt-hours for training. Entire power plants run hot for them. NVIDIA GPUs used for AI easily pull 300 watts per card, and you need hundreds of them to train something big. The CL1 does this with a fraction of the energy and still delivers amazing results. This is already a huge advantage, especially if you think about climate change and sustainability. Companies could revolutionize their data centers with something like this. Lower electricity costs, less CO2, more power. This isn't theory, it's already in the specs from Cortical Labs. And it gets better, because the neurons learn so efficiently, they could solve complex tasks faster than conventional AI, without having to feed them terabytes of data. This makes the CL1 not only green, but also damn practical. What can the CL1 already achieve? There are concrete applications that are either running or about to launch. In medicine, this thing is worth its weight in gold. Imagine you want to understand Alzheimer's. With the CL1, you can see how real human neurons respond to diseases. Researchers could test drugs by feeding the cells with active ingredients and watching what happens. This would be faster than computer models and more accurate than animal testing, a huge step for the pharmaceutical industry. An example, let's say a new drug is supposed to improve signal transmission between neurons, like in dementia. With the CL1, you could measure live whether the cells fire faster or whether they become more stable. And this in weeks instead of years. Or think about epilepsy. Researchers could test how neurons respond to seizures and which medications calm them down. In robotics, the CL1 is also a game changer. Robots with normal AI need huge amounts of data and power to adapt. With the CL1, they could learn like humans, flexibly, intuitively, with minimal energy. Imagine a robot working in a factory and suddenly having to deal with a new tool. The CL1 could learn this by simply trying it out, without you having to reprogram it. Or a household robot that notices how you like your coffee and adapts without you having to write a manual for it. Cortical Labs even offers wetware as a service. You can use the CL1 via the cloud without owning it. This is already in planning, and from June 2025, it will be delivered for $35,000 US. Not a high-end toy, but something researchers worldwide can use. But now comes the catch: ethics. The CL1 uses human cells. Is this thing alive? Cortical Labs says, no, these are just 100,000 neurons. Your brain has 86 billion, no consciousness, just a tool. But not everyone is convinced. A study from CL showed that neural networks in vitro sometimes show unexpected patterns. Some researchers say this could be primitive sentience, a kind of rudimentary consciousness. Others wave it off. That's like saying a calculator thinks. The truth, nobody knows exactly because we can't even define where consciousness begins. What we do know, Cortical Labs is working with ethicists to clarify this. They want to make sure no boundaries are crossed, but the debate is heating up. One critic even said, if this thing ever says no, what do we do then? What do you think? Is it just a clever tool, or will it eventually become creepy? The question is open, and it will occupy us for a long time. Now let's jump into the future. This is no longer real, but speculation. Imagine the CL1 becomes standard. Robots everywhere run with biological chips, learn like humans, and need hardly any power. In medicine, you could grow neurons from your own cells. Your doctor tests medications on your personal CL1 before giving them to you. Diseases like Parkinson's could be cured this way because we know exactly how your neurons tick and how to repair them. Computers would become so efficient that they would enter every home. No more huge energy consumption, but smart systems everywhere that adapt themselves. But there are also dark sides. If machines learn like we do, what does that mean for jobs? Will robots eventually become creative and replace us, for example, by making art or writing stories? And how do we prevent such technology from being misused for surveillance or autonomous weapons that decide for themselves whom to attack? The boundary between human and machine could blur. Perhaps we will soon interact with technology that is more similar to us than we think. Education could also change. Children learn with biological computers that adapt to their learning style, almost like a teacher who always knows what you need. These are all possibilities that the CL1 could open up, but it's up to us how we use them. Maybe in 20 years, we'll see households where the refrigerator with neurons decides for itself what you should eat based on your day. What do you think about this? The CL1 is already real and delivers amazing results. Faster learning, hardly any energy, applications in medicine and robotics. But the visions of the future make it all really exciting, or maybe scary. Write to me in the comments. Is this the future you want, or more of a nightmare? I want to hear your opinion. If you like this update, then leave a like and subscribe to the channel. And if you activate the bell, you'll even be notified when we upload a new video. I hope to see you next time. Until then, stay real.